Welcome to today's online web session on the topic of Kubernetes cluster inventory setup in 5 minutes. My name is Matthias Scholz and I work as CTO at Virtual.io. For today's web session, I have a guest from our R&D team, Head of Development, Fabian Klose. Today, we would like to show you an approach how to inventory a Kubernetes cluster in less than 5 minutes. Fabian, first question, why has Kubernetes become so important?
Kubernetes has become the standard for deploying container-based applications, and with this, it becomes important to include the Kubernetes infrastructure in the context of IT service management and IT operation management.
We start right away with a live demo, and Fabian would like to show us the following. Install the one importer. One importer is the agent of Virtual.io that can inventory things. Fabian will install the one importer to our Kubernetes cluster. Then Fabian shows us how we can use the topology analysis to understand the structure of our Kubernetes cluster. Then he gives us an insight how we can make a reporting or an analyzing about the data that we inventory of the cluster. And we show you how we can make an assessment for the product lifecycle and security things, and how we can verify IT governance rules. Fabian, the stage is yours.
Yeah, thanks, Matthias. So we will start with a short look into our console, so I can show you what is the example Kubernetes cluster for today. We have 3 nodes running here. I can show you. So just for a small example, today we have 1 master node and 2 worker nodes. And we also deployed a simple application. We deployed an Nginx web server. And we have 3 running pods of this Nginx deployment. And that's it. And that we want to inventory now in our Virtual.io environment. We will start from scratch. We have a completely empty new environment. That's why we get this little pop-up window with a little helpful wizard. And we can start and select that we want to start with our Kubernetes cluster. And the first thing we have to do is to download a configuration file. And that includes everything we need to deploy our integration into our Kubernetes cluster. The second step, we will copy our command to apply this configuration in our cluster. And we will see our environment is already waiting for us to apply this. So I already copied the file I downloaded to our server here. And now I just have to execute the command I copied before. So that's it for the integration. And right now we can go back to our application and see the one importer is already connected. And right now he's collecting the necessary data from the Kubernetes API. And we will just have to wait a few seconds for the first data. There we are. So now the integration finished and we are under 5 minutes, I think. But we will use the time to show you what we have done now and what the data looks like. So like every other data we include in Virtual.io, we can now see every instance in our asset and configuration inventory. And we can take a look into every single item here. And for example, we can take a look into the master node here. And we have here a lot of information like the IP address of this server. And to get a better overview, what kind of data we have imported right now, we can take a look into our topology. So we have a short or a small picture right in here, but if we go to our cluster and take a look into our full topology, we can say we want to see everything in both directions, and we will see our complete cluster infrastructure. So now we see we already imported 166 instances. That's a lot for the 3 running Nginx pods we had there, but we can see we also included and imported the system internal kube system namespace with every role Kubernetes has inside itself. That's something that can be filtered, but for now we have imported it also. And we see our 3 nodes that providing our Kubernetes cluster, and in the default namespace, we can see our Nginx deployment and the 3 running Nginx pods. And we have also deployed an Nginx service to expose these web servers. So, and if we want to have some information about these running pods, we can use our data reporting and say, for example, we want to see what pod is running in, or how many pods are running in which namespace. And we can also say, okay, but I want to see the name of these pods and maybe on which node they are running at this time. We can use our data reporting here to build tables or graphics by our own. And maybe we can add the IP address of the pod, and we can say, okay, we will filter the kube system namespace here because we want to see our only our self-deployed pods, and we see our 3 Nginx pods and 1 pod for our one importer we deployed. Our one importer is running in his own namespace. Okay. Because of the information we get from the Kubernetes API, we also have information about the running versions from the Kubernetes itself and the operating system and the container runtime. So we are using containerd as container runtime, and our nodes running on an Ubuntu version. And we see we are using Kubernetes version 1.26.1, and we are not up to date, we see here, because there's already a newer patch available, so we could do an update here. And we get an assessment for this version we are using, saying, okay, we are not compliant with our lifecycle rule here, and we have to update to bring this back into a green state. Also, we have an example governance rule included. It's some best practice saying that it's good to have the kubelet and the kube proxy service running in the same version. And we can see all of our nodes are compliant to this rule because they are all running the kubelet and the kube proxy in the version 1.26.1. Yeah, I would say that's enough thing for today.
Perfect, Fabian. Then let's switch over to the slides again. So thank you, Fabian, for the live demo. The integration looks very simple, and it's exciting what you can do with the Kubernetes data now. What else is possible?
Of course, you can still complete the inventory. For example, you can record the infrastructure under the Kubernetes cluster. This can be the virtual machines in the cloud, or your complete virtualization platform, or even the bare metal machines in the end. Then you can also capture the application running in the pods. This allows you to capture the complete application stack of processes, configuration, services. And at the end, you can inventory all kinds of artifacts that are necessary for the deployment of applications and that you would like to have better under control.
Cool. And before you ask questions, let me summarize what Fabian has just shown us. With a minimum of effort, Fabian set a Kubernetes cluster inventory in under 5 minutes. Often we have the argument is often that you don't need an inventory because you are using infrastructure as code. But why does inventory have such great advantages? The inventory captures the real reality. Infrastructure as a code only defines the target. The inventory data is much easier to access and to understand. That gives many more colleagues of you the chance to understand and use it further. The continuous inventory also captures dynamic changes. For example, how many pods have been instantiated for a service. Furthermore, time-changing assessment, such as for release, patch management, or new IT security vulnerabilities, can be carried out. And with this availability of the inventory Kubernetes data, there are many added values and possible use cases. You can detect changes in your Kubernetes environment. You can monitor change request executions for planned or unplanned changes. You can make an assessment for your product lifecycle. That means release and patch management. You can make an assessment for IT security, and you can make verification for IT governance. Thank you for your interest and your time.